Here is video part 3 for finding a percentile within a normal curve. We talked in the very beginning about density curves and how normal curves are a special kind of density curve. And then I talked about the rule of thumb. If you remember this video, we talked about finding percentiles within deviations from the mean. So 1 deviation above the mean, 2, and using this rule of thumb. But again, it was only acceptable to use this rule if you land on exactly 1 or 2 or 3. And so many people ask, well, what do you do if, your z-score lands in between 0 and 1, like 0.7 or, I don't know, 1.2? How do you find a percentile? Well, it's relatively easy, and what you need is a calculator, and I'll show you how to do that. There are 3 separate kinds of possible calculations you can do, and that's it. The way the calculator finds the percent under the curve is based on these 3 kind of methods. At most, meaning no more than or less than, those are the same kind. This is where your area under the curve will be shaded to the left. The second kind, at least or more than, you would shade to the right. So you want, I don't know, the probability of getting a 24 or higher on the ACT, something kind of like that. And then in between questions. So these 3 are the only 3 that you would be asked, and I'll show you how to find these on the calculator. So once you turn your calculator on, you'll be typically on your main screen. Doesn't matter if you have anything here, you can clear it or not, that doesn't matter. But to find this calculation, normcdf, how you get there is second and vars on the calculator. Now the top one, number 1, I've never used before. I don't know what it's for, so totally ignore that. That's what I do. And number 2 is what you want. So hit enter. And then here are the 4 things that you need to enter in the calculator. Now my version is a little bit updated. If you don't see the screen show up, typically what happens is, here, I'll come down here. Some of the old versions just show up with this on the main screen right away, and you don't have the prompter to tell you, but these are the 4 things that need to get entered into your equations. So the first thing you need to do is fill out where you want to start, left bound, where you want to end, high bound, and then the last couple things, mean and standard deviation. So I'll go back to my screenshot here to make it just a little bit easier. But let's say we were talking about getting, I don't know, here, I'll bring up this curve. Let's say your question was, what is the probability of getting at most a 12 on the ACT? Let's do it in between instead. Let's say, what's the probability of getting a 17 on the ACT? So since this doesn't land on one of those deviations, how do you do it? So if we want at most a 17, our low bound would be negative infinity. And negative infinity, how you type that in the calculator, is just negative. Now be careful, you don't want to use subtract, you want to actually use the negative symbol here, otherwise it will create an error. So let's say negative infinity, so just enter in a very large negative number, doesn't matter how big that is, up to the value of a 17 on the ACT. Now we talked about the average being an 18 on the ACT, so that goes for the average spot, and then it varies by 6 points. When you hit paste, this would show up on your main screen, so you can go back and see. There are 4 things to enter in. When you hit enter, it will give you the percentile of getting a 17 on the ACT. So 43.38% would score a 17 or less on the ACT. Another type of question that you could calculate would be more than. What is the probability of getting this score or higher? So the only difference is we won't be using negative infinity, we will be using a positive infinity. So this needs to go into the second spot. So more than, I know the curve kind of looks like it has an endpoint, especially when you're looking at this one that said 0 to 36. You can't get a negative score on the ACT, I totally get that. But technically, by definition, the normal curve doesn't end. And that's why we use the value of infinity, or a very large positive number, negative infinity, a very large negative number, even though it doesn't show up on your scale above. So let's say we wanted to find the probability of getting, I don't know, let's say you got a 28. That seems like a pretty good score, right? So we're going to go to second vars, normcdf again. What are the chances of getting a 28 on the ACT or higher? So I'm going to enter in any positive infinity number. It doesn't matter how many 9s you have. I typically use about 5 or 6. average for the ACT is 18. It varies by 6. So what are your chances of getting that or higher if the average is truly 18 and it varies by 6 points? 4%, well, 4.7%, so about 5% chance that you would score a 28 or higher on the ACT. Man, that means you're in the top 5 percentile. But again, given if it really is true that 18 and 6 are the two mean and standard deviation for the curve. Now, I'm not quoting this as being completely accurate, but let's just say if that were true, 18 is the average, it varies by 6 points, then wow, 28 on the ACT, you're in the top 5%. How cool is that? The last type of percentile question you could do would be in between. What are the chances of getting in between a couple scores? So again, let's say we want to do in between, well, I don't know, let's make it in this region. Can be anywhere in between you want, but let's say a 26 to a 28. Sure, why not? So instead, when I go to second and vars, I set a 26 to 28, I think. So 26 would be the lower bound, 28 would be the higher bound. If the mean truly is 18 and it varies by 6 points, hit enter. What is the percent chance that you have of getting that? It would be, wow, 4% again. So pretty easy way to calculate with a calculator. Now, if you don't have a calculator, you'd have to use some kind of table, and I won't show you that on this video. That I'll have to try to upload another day. So hopefully that helps.